We use Jenkins as our build server for this project. We configured 2 jobs in Jenkins based on 2 different branches of our GitHub project. Any changes pushed to GitHub branch would trigger a new build in Jenkins, and we implemented that using GitHub webhooks. Based on the results of the build, if it was successful or a failure, we sent the email notifications to the users. As you can see, a change has been pushed to GitHub, and once it has been completed, a new build has been triggered. So you can also see that Jenkins has implemented a build history in itself. So since the build was successful, we get a success email notification, and same would happen in case of a build failure. We used the same JSON project for our second milestone. We got a summary of our test results using Surefire plugin, and using the Emma plugin, we got a test coverage report. In order to improve the code coverage, we used Randoop in order to generate JUnit tests. As you can see, it helped us improve the code coverage. We implemented basic static analysis using PMD, and we also added additional rule sets in checkstyle in order to get custom metrics. We implemented security token detection and code duplicate detection using CPD plugin. Finally, we gated the builds which did not pass our analysis thresholds, and we sent email notifications to the user about reverting the commits. We used the Node.js application as the target project for our deployment milestone. On any changes pushed to the GitHub repo, if the code analysis is successful, an endpoint is triggered which starts the deployment process, and on a droplet which is provisioned and configured using Ansible. We use New Relic as our monitoring service, which sends email alerts if the CPU or the disk IO usage is greater than the preset threshold. We also configured it to autoscale using webhooks. We implemented feature flags using a global Redis data store. Finally, we set up a load balancer to switch traffic between normal and canary release in the ratio of 2:1.
For the special milestone component of our project, we implemented a continuous monitoring framework that is capable of identifying DDoS attacks and performing countermeasures on such an attack. DDoS, or distributed denial of service attacks, can originate from multiple sources all across the internet. This makes it really difficult for us to block or even identify such an attack. The attack typically consists of a large number of requests being made to IO-intensive endpoints of the application. Given all the pain points associated, we tried to come up with a framework that could address a few of them. The first step was to read all the HTTP requests that the application was receiving and to identify a possible DDoS attack. One such signature could be when an exceedingly large number of requests are being made to a single resource of the application. Once the identification is made, we send a Slack notification to all the members of the team. Since the attack can happen at any given point in time, night or day, sending an app notification to all the team members increases the odds of it being received and addressed. Within the notification, the user is presented with 3 different options, each of which can be performed by just clicking on the button. He can either choose to ignore it or remove the entire resource that is being targeted by the attack. He may also choose to migrate this resource onto a cloud-hosted CDN or a content delivery network to mitigate the effect of the DDoS attack. To give a quick example, I'm just going to quickly demo the framework that we built. This is a Hello World application that we've written, and it consists of 2 resources. The first one is the Hello World text, which is a really small text file, and the second one is a large PDF file, which is a good place for a DDoS attack. To simulate a DDoS attack, I'm just going to make a couple of curl requests to this particular PDF. And once the framework identifies a DDoS attack, it's going to send a message to our Slack. As you can see, we got a message notification which says 4 requests were made in a minute, and the targeted resource was this big PDF. Of all the three functions that we can do, let me quickly demonstrate the pull down target resource function. Essentially, this one will remove the link to the particular PDF so that the attack can be stopped. Once I do this and refresh the page, we can see that the link to this particular PDF has disappeared.